Extraordinary claims require extraordinary evidence, and if that evidence is easy to understand, and anyone with the internet can vet and peer review and confirm or deny the veracity of it, that's even better. This is exactly that. If you are watching this video, you can find and verify everything you are about to see, and also critique and review it if you are a skeptic. So first, what this is not. This is not like a hurricane warning where we're almost certain it's coming and resources are put in motion and even evacuations and fear-based behavior might ensue. Right now, this is a small step, an intermediate step, but right now it is not yet what can be called actionable. What absolutely is a fact is that small portions of the Earth's active faults may be identified as being most at risk with 70 to 80% accuracy on any given day. Let's see what this looks like. All earthquake data can be verified through any reporting agency like the USGS. On consecutive days, notable events struck Japan and New Zealand in the middle of November. Quite obviously, the New Zealand event was one of the more impressive events in that region ever recorded. The day before the first earthquake struck, this is what the alert looked like. Alert stars indicated the north and south areas of the West Pacific were on watch, and in consecutive following days, Japan and New Zealand struck. No matter what, we try to analyze the Ring of Fire every day, but every once in a while an alert zone pops up elsewhere, and one time only, an alert star was posted outside the Ring of Fire. It was October 29th over Italy, where a magnitude 6.6 struck the very next day on October 30th. Well, how about the very next large earthquake, a magnitude 6.4 in Chile on November 4th? While we were monitoring a few areas to consider for later alerts at the blue lines, the primary alert clearly rested over Chile with its alert star. Sometimes you don't even need the map, such as when only a few areas or a small region of the globe is on alert, such as when subterranean signals we've termed blot echoes struck the Philippines and Indonesia, and continued for hours even after this posting wasn't so minor by the time a magnitude 6.6 struck Indonesia the very next day. Perhaps the best examples of not needing a map came with the first alerts ever made on November 8, 2015. Granted, we did wait to start until the signals were utterly clear, but within 5 days, 2 of the 3 alerted regions are struck with large earthquakes. Whether we picked our moment or not, this is extraordinary evidence that this thing works. Or how about 2 days after that alert, in between the 2 hits for the first ever alert in Sumatra and Japan, we eyed Chile and were even able to clarify maximum magnitude based on pre-seismic signal. The very next day, 2 magnitude 6.9 earthquakes struck Chile. We actually were kind of on a roll in that first month. Just 9 days later, we looked at the Central America and South America convergence region spreading down to the Peru Bulge. While space weather indices were quiet then, the alert persisted 3 days, specific space weather signals intensified, and 1 day after that, 2 magnitude 7.6 earthquakes struck in Brazil and Peru. So while the alert maps cover a range from 2 to 25% of the active faults of Earth, they average between 10 and 20% of those considered to be most active. Now, despite that restriction, the majority of large earthquakes are hitting these relatively small alert zones. You can read more about this in the document at quakewatch.net that details these efforts in full. Top right on that page, you can actually find our peer-reviewed works on how the sun triggers earthquakes. The document we're pointing at there is open source and a living document that we will update with new data from time to time as warranted. At the time of this recording, we last updated it on Christmas Eve. Something important to note about how the process currently works. While we used to post predictions of magnitude 6 earthquakes to occur, we have transitioned to a risk forecast model based on pre-seismic factors, posting alert zones every day, regardless of maximum magnitude forecast at that time, rather just based on where the risk is highest. When a large earthquake does occur, we simply look at the most recent alert map and see if the area was at risk according to the model. After that, you compare how large your alert zones were to your success percentage. Now, it is possible to do something like just mark Japan, Indonesia, and Chile every single day and get a much higher percentage of earthquakes than area covered, but that's not really in the spirit of these efforts, and as you could see, the regions do jump around a good deal in our model, and they include regions you'd normally not think would be regular rumblers, like Italy, like the United States, like parts of the Middle East. Certainly not as much as the Ring of Fire. During the time the model has been in play in the real world, streaks of 4, 5, and even 9 in a row have been recorded in terms of magnitude 6 and larger earthquakes hitting the model alert zones. If you read that document on QuakeWatch.net, you'll find a lot of the work that went into the current model, from the subterranean signals we've termed blot echoes to the types of atmospheric and electrical phenomena that may be responsible for things like earthquake lights and strange animal behavior prior to some large earthquakes. Currently, we're looking at outgoing long-wave radiation, precipitation, atmospheric pressure, pressure gradients, temperature gradients, cloud cover, numerous space weather factors from geospace to the sun, and of course the subterranean blot echoes. Again, it is vital that no one confuse this material with something more than it is. Alerts are not cause to panic, and they are not yet viable means of devoting resources. The accuracy is nowhere near what meteorologists can do with hurricanes and typhoons. However, what has happened here came from combining many small pieces of an incredibly complex puzzle. Beyond the statistics, which are absolute fact, we claim that this system, or at least certain portions of it, has merit and should be investigated to see if accuracy can be improved while alert zones can be reduced in size for greater specification. How about we take a look at one of our misses? Back on December 8th, 2016, this was the alert map, and a magnitude 7.8 struck the Solomon Islands just east of one of the alert zones. It was a close miss, but a miss. However, that was also a day a magnitude 6.5 struck California during a red alert for the coastal region there, with the third place shaker of the day hitting at 5.9 in China in their alert zone, and the fourth largest events occurring in Chile in the fourth alert area. No question, we missed the largest and most important quake of the day by a few hundred kilometers, but the four largest seismic areas of the day roughly occurred according to how the model believed the energy was trending in a manner to trigger seismic pressure. If you read that document, again at QuakeWatch.net, you'll find we had a trial period followed by the current model implementation. During the current model run, these are the largest 5 seismic events. It's only been a few months, but certainly a highly active few months. 4 of the 5 were hits for the model, and that miss was a close one. We just looked at it. That was the day the other 3 alert zones all did get hit with the next largest earthquakes. Second place that day was the 6.5 in California. That was the only magnitude 6 event in the United States during the model run, and it was a hit, along with 2 other smaller events that the USGS has declared to be significant as well. The magnitude 7.6s in Brazil and Peru during the trial period in 2015 were actually the 4th and 5th largest seismic events during the current model run and the testing period combined. One day, August 11, 2016, our alert was based solely on coronal hole structure, and the islands of the Southwest Pacific were put on alert. Large events struck New Caledonia and Fiji the very next day. Of course, the only alert star ever outside the Ring of Fire got struck in Italy the day after it was posted. These here are just some of the events that indicate the merit and the breadth of applicability of this model. Is it ready to command action by governments and citizens? No. But is it potentially a step in the right direction? It is difficult to argue otherwise. I assert that this is indeed extraordinary evidence of an extraordinary thing. There are already thousands of people predicting seismic activity using this model, including students as young as 13 years old. Won't you join us?